Students, you are welcome back to this online class. Today, our topic is basic ideas of electricity. I'm very sure electricity is no longer new to you because without it, you won't be able to operate your radio, your television, your computer, and all other electronics devices. And so there is need for you to have the basic ideas of how it works, what are those components that make it to work. So electricity is the flow of electrons or electric current. Electron is the negatively charged particles of atoms of any element. I know you must have learned about the first 20 elements. We have hydrogen, helium, lithium, boron, and so on. You have carbon dioxide and all the rest. So there are three particles of each of them. Hydrogen, for instance, has three particles. We have the proton, we have neutron, we have electron. Electron is negatively charged. Proton is positively charged, while the neutron has a neutral charge. It's neither positive or negative. And so the negative charge, the negatively charged particle of atoms of any element is called electrons. A conductor allows electrons to move freely since they are strongly attached to it. A conductor can be your wire, your cable, any metal. So any metal is called a conductor because they allow free flow of electric current. What are those basic components of electricity? Number one, we have current. Electric current is the flow of electron in a circuit. The unit of measuring electrical current is in ampere. Just like you measure length and you say it's centimeter. You measure weight, you say it's in kilograms, and so on. So that is the reason, that is the same way we measure electric current in ampere, and you have the unit in capital letter. If it's 3, you have 3 amperes. The instrument used for measuring the quantities of electric current is called ammeter. We have types of current. We have direct current. Direct current is the current that flows in only one direction. Then we have alternating current. The alternating current is the type of current that reverses its flow in the circuit. Electricity can be generated in different ways. We have water power system, which is our hydroelectric power. That is water power system. We have wind through the dynamo. You must have been hearing of that before. Then we have the accumulator. That is your battery can generate electricity. Then we have a generator. That is the mechanical force in the generator you are using at home. All these are various ways of generating current. So apart from the one that is being generated through accumulator, all others come from alternating current. While the one from your accumulator or your battery is from direct current. The second component of electricity is voltage. This is the force that moves the current around the circuit. The unit of measuring voltage is volt. What we are saying is that their voltage will have remained on a spot, just like where you are standing or where you are seated. But the force that is moving it from where the point of generation to the point where it will be utilized, that force is called voltage. The electrical measuring instrument used for measuring the amount of voltage that moves the current around the circuit is called the voltmeter. It's called voltmeter. Voltmeter. Voltage is also called electromotive force or potential difference. The third component of electricity is resistance. Resistance is the ability of a material to oppose or resist or withstand the free flow of electric current in the circuit. The component used for resistance is called resistor. The unit of measuring resistance is in ohms, and the instrument used for measuring resistance of a material is called ohm meter. So when the current is flowing, when you know that the amount of current that a component or an appliance we need is 2 amperes, and from the point of generation where they generate the current is more than that. So you can use the resistance to reduce. You can use the resistor to reduce the flow of current, so that the higher the resistance, the lower the amount of current that flows in the circuit. So you will learn more about that as we continue. So the unit of measuring the resistance is in ohms, and the instrument used is called ohm meter. There is a scientist. The name of the man is called Ohms. He's the one that studied the movement of the current in a circuit and the impact of resistance on that current. And so he propounded a law, and the law was written after his name. The law is called Ohm's law. Ohm's law states that the current that passes through a metallic conductor is directly proportional to the potential difference across its terminal, provided temperature and all other physical properties remain constant. So we can interpret what the law by saying current equals to voltage over resistance. What that one is saying is that all things being equal, because those factors that are mentioned, the temperature, the physical properties, you must have learned that one in your social studies. These are humidity, the heat, the rainfall, and all the rest. All these also affect the flow of current, and that's why sometimes during the day when the sun is so harsh, the current may be a bit low, as in the influence or the effect of heat on the cable outside. And so during the night, you see it will be better. So if all these properties are having constant value, then current, which is I, will be equals to voltage over resistance. That is, I equals to V over R. The arrangement of resistors in a circuit. There are 3 ways of arranging resistance. By the time we continue with teaching, I will show you the component, the picture of the component. Then you will see the symbols, so that whenever you see or you come across such, you'll be able to identify them, that this is a resistor, this is this, and this is that. Now, we have the parallel connection. When you are connecting resistors in a circuit, we have a parallel connection. This is the situation where all resistors are connected side by side. As you see in the picture below, you have the R1, you have R2, you have R3. Something that be like wavy line. That is the symbol, the circuit symbol for resistors. And so if you are to calculate the total resistance, you see the formula there in the front. 1 over RT, that is total resistance, will be equals to 1 over R1 plus 1 over R2 plus 1 over R3. And so we are going to apply it and also look at some examples. We have series connection. This is the situation in which resistors are connected end to end. As you see it in the next picture, you see the series connection and you see the way they were arranged in the circuit. The R1, R2, R3. At the lower part, you have your battery there connected to it. And so the formula will be RT equals to R1 plus R2 plus R3. Meaning that if you have the first resistor is 2 ohms, the second one is 3 ohms, the third one is 1 ohms. So you just add them together and that form the total resistance. You will look at the examples as we continue. Then the third one is combination of series and parallel connection. You can see the R1 in the diagram below, and you see another parallel connection. So how do you tackle this and what formulas are you going to use? We will also look at it as we continue in the examples. He said the examples of the arrangement of resistors. So example 1, you have the question there and the circuit diagram. You will see it telling you to calculate the total resistance in parallel, in series. Example 1 says 3 loads of resistance 2 ohms, 4 ohms, and 6 ohms are connected in series. Calculate the total resistance. Calculate the total resistance. So as you have it there, the formula will be R equals to, or RT, as you have it in the previous formula, it will be R1 plus R2 plus R3. Then you just add it up and you have your 12 ohms as your final answer, which is the total resistance. Then the example 2, that is the example under the parallel connection. In a parallel circuit, the 3 resistors connected are 2 ohms, 5 ohms, and 10 ohms. Calculate the total resistance in the circuit. You have 1 over R, which is the same thing as 1 over RT, equals to 1 over R1 plus 1 over R2 plus 1 over R3. So you say 1 over R, the value of each of them, you put it as 1 over 2 plus 1 over 5 plus 1 over 10. Then you look for the LCM. LCM of the 3 of them is 10. So 2 in 10 give you 5 times 1, 5. 5 in 10, 2 times 1, 2. Then you have 10 in 10, which is 1 times 1, give you 1. So when you add them together, you have 8 over 10. By the time you divide it, you have 0.8 ohms as your final answer. Then we have the combination of series and parallel connection. The first thing you do, you say the question, you say calculate the total resistance in the circuit below. So you have the first resistors as 4 ohms and the second resistors as 2 ohms and the third one as 4 ohms. 2 ohms and 4 ohms are parallel to each other, while the 4 ohms, the first 4 ohms, which is R1, is in series with both of them. So the first thing you do is to calculate the total resistance in parallel. And so when you want to calculate the total resistance in parallel, you said R1 of 1 over R equals to 1 over R1 plus 1 over R2, which is 1 over 2 plus 1 over 4. Then you have the SEM as 4, and 2 into 2 in 4 is 2 times 2, 1, plus 4 in 4 give you 1 times 1 give you 1. Then by the time you divide, you add those two together, you have 3 over 4. 3 over 4 can also be by the time you divide it, you have 0.75 ohms. So 0.75 ohms will now be in series with the first resistors that you have as 4 ohms. So by the time they are now in series to each other, so you can now say resistance in series, which is, you state the formula again, which is R equals to R1 plus R2. And what do you have for R1? You have 4 ohms. You have 4 ohms. And R2, you have for R2, the one that you just finished now is 0.7. So you write it there. By the time you add the two together, you have 4.75 ohms. Disregard that 6 is 4.75 ohms because your first resistance is 4 ohms. So we now have the total resistance in that circuit as 6.75 ohms. Now, there are components of electric circuit. When you see a circuit, what are those things that will be there? Then, electric circuit is the path through which the current flow. It is for conversion of electrical current into useful purpose, such as lighting and heating. Electrical circuit is connected and fitted with devices that control and measure the current and energy used in the process. So you can see there, the ammeter is there to measure the amount of current that flow from and the voltmeter is also there to measure the voltage that is there. You have the resistor. You have the rheostat. Rheostat is just like inductor. Inductor is the one that allows the current to move freely. So it's like resistor. They perform the same function, but that resistor is a wire wound resistor. If you have seen the coil before, they wound it round the metal. So that is rheostat. And you have the cell. This circuit is complete. If those components are not there, the circuit will not be complete. Then we have basic, those ones are those that we have explained before. The battery, which is the one that supplies the current, and you have your ammeter to measure the amount of current that flows in the circuit so that it will not damage the other components. Then the resistors are also there. Then you have your rheostats as I've explained before. So if there is any question, I said the source of EMF, that is the source of voltage, which is your accumulator. Your accumulator can be primary cell or secondary cell, as you have learned in your basic science. If there is any other question, I will be able to answer you as we continue the lesson. God bless you. So